Hey guys, I'm Sun. I'm a privacy and security researcher, and you're watching The Privacy Guides. This is episode 9 of the Bitcoin series. It's a series of 10, so we're going to be back to regular programming shortly. Stay tuned for more privacy content. But today I am thrilled to finally share with you a little piece of technology that I've been developing over the past few months. It's something that I developed to scratch my own itch. When I started, learning about Bitcoin, paper backups is something that was mentioned a whole bunch of times. Paper backups is essentially us storing a mnemonic, a set of words on a piece of paper so that if ever our hardware device fails us, it is possible to recover it. It's essentially crucial to one's setup. Now, something that I felt uncomfortable with is the fact that paper backups tend to be essentially words written on a piece of paper. It's something that is prone to exfiltration, especially in the context of multi-signature wallets. If one is storing a device with its backup in a vault or at a friend's house, well, that person could just read those words off a piece of paper. Now, again, one should always use a passphrase to extend the seed, but nonetheless, I didn't like this. I was looking for something that was more robust, something that would be encrypted. So I started researching this, and as you guys know, if you've been watching the Privacy Guides for some time, I came up with a way of encrypting, essentially words using PGP. Oh, and then there's an alarm system outside. Give me a second, I'll get my paper backup actually. Good, that wasn't long. So I came up with a system to encrypt strings of text using GNU-PG and then storing them inside of a QR code. But the process was kind of painstaking, very hacky, and it wasn't something that was easy to replicate. So I came up with this. What you're looking here, this is a Raspberry Pi running Raspbian. It's a Debian operating system. It's a Raspberry Pi that has a whole bunch of scripts built into them that are all open source that you guys can peer review. If you're a privacy or security researcher, actually, please do peer review this guide. At the bottom of the page that I'll be sharing in the comments or in the description, I should have said, there will be a link to that. So essentially, this allows us to store secrets, and it doesn't have to be a Bitcoin mnemonic. It can be anything that you can type in using a keyboard, and it generates things like this. So what you're seeing here, that is an encrypted paper backup. Right here, that's a short version of the SHA-512 checksum of the whole content that has been encrypted. So it does support ways for us to audit, or what's the word I tend to use for this? Anyways, confirm the integrity of paper backups. So I will show you guys how this works and what you can do with it first, and then I'll show you guys how to set up your own, and I'll discuss bits and details of how I came up with this and why I think it is the world's most advanced paper backup hardware device that you guys can actually set up for yourself quite easily. Now, before I go ahead and do this, as always, everything you read down there in the comments, that might be someone trying to steal your Bitcoin or steal your money. Please be mindful of this, and I'm counting on each and every one of you to report spammy comments so that we get to keep the conversation going. Am I filming up there? Yes. And I also want to mention that ShakePay, a Canadian Bitcoin exchange used by Canadians to buy and sell Bitcoin, has supported the Privacy Guides and has sponsored this whole Bitcoin series. Without their help, it wouldn't have been possible. So thanks so much to ShakePay for helping out and caring about this kind of research. So what we have here is a Raspberry Pi 4 with an Adafruit hat. It's a display. This display here is actually pretty high resolution. Let me switch to this overhead cam actually, so I make sure that this stuff is in focus. So what you're seeing here is actually a pretty high resolution display that is showing us the terminal. This is powered off an Aukey USB-C battery, which is amazing. It makes so that this setup is portable. It can be used in the field. I'm using the actual Raspberry Pi keyboard. This here is a micro SD card reader. Whoa, stop doing this, focus. This is a micro SD card reader that is used to write encrypted QR codes as JPEGs on this so that they can then be moved off this air-gapped device. While I'm talking about air-gap, this here is running, Debian Buster, and it is running it in a read-only way. So this device cannot by mistake store anything you enter on it, on the micro SD card. It is read only. And it is also not connected to any form of networking. So networking is explicitly disabled on this device, which means that this device here is actually a cold device. It is used to air gap sensitive use cases away from other computers. It is capable of provisioning or validating the integrity of Trezor devices. And it can create or read QR codes thanks to this little webcam here. This webcam here is, I think it's a Microsoft Microsoft HD 3000 something. I'm not sure of the exact model, but it is in a list of supported devices. Sorry. Okay, so how the hell does this work? What can it do for you? Well, it can encrypt any string that you can type in with the keyboard and generate one of those. So let's do one right now. So if you type pi, raspberry is the default password here. I have created signed releases that you guys can use to just try this out. And then if you type QR backup, enter, it will ask us to format the USB flash drive. This is a micro SD, so I'll say yes. I need to enter raspberry again. Oh, that's definitely a typo. Sorry about this. Okay. And now it is asking us to type a secret and press enter and then Control D. So I will type a secret. It will be foo, enter, Control D on the keyboard, foo again, enter, Control D on the keyboard. Then it is asking us to type a passphrase and press enter. So I'll put a really shitty one, but if this is a secret that you want to really protect, you would want something that is very, very long and random, kind of the same as what you would use for a password manager, for instance. So there we go. Now, whoops, damn it, son, damn it. Let's do this again. So by the way, it is essentially using bash scripts. So it's not necessarily perfect from a UX perspective, but it was designed so that you guys can peer review the code and really know what's happening under the hood, and it all uses open source stuff. So foo, Control D, foo, enter, Control D. Then putting that passphrase twice. It has a feature to show the passphrase, something that usually is not the case in command line. I won't show it, but you can see what you typed, and that's great to prevent typos. Enter. And now, as you can see, it is using GNU-PG to encrypt this. So what you're seeing here, that is the encrypted payload. This here is a SHA-512 hash of this payload, and this here is the short hash. So the short hash is what you guys have seen once here. I've showed that, I believe, a few times throughout the Bitcoin series. So that is super helpful. And if you click yes, it will actually show a QR code of that hash, which you can then scan using an iPhone, for instance. The camera app can detect QR codes, and you can store that hash in a password manager so that when you want to validate the integrity of paper backups, you can just scan them and compare that with what you have on the password manager. It's super useful in the field. Okay, so once this is done, I remove the micro SD card and I'll switch over to my Mac here, plugging this in. And if I pop open the no-name card, this here is what we have. So we have this really nice little file here, and that can be printed using a network connected printer or anything. This is encrypted with AES 256. So it has like the highest level of encryption, symmetric encryption that one can do using GNU-PG. There are more robust ways of doing this, but this is way good enough, I guess, for 99.99% of use cases. And everything, as I mentioned, is open source, so you can look at the source code and see if that is good enough for you. I mean, GNU-PG is being critiqued over the years for not using the most advanced cryptography, but that is really from a theoretical standpoint. This is, if you're using a very strong passphrase, impossible to break. And quantum resistant, because we're not using public key cryptography, which is kind of weaker from a quantum computing perspective. This is using the symmetric side of things in GNU-PG, and I chose GNU-PG so that it is future-proof. It uses off-the-shelf open source projects so that you don't need this Raspberry Pi to recover a backup using these encrypted paper backups. This is a QR code, and its payload is just a GNU-PG armored encrypted string. Okay, now let's say we want to recover from what's on the screen here. You type QR restore, enter, and then it will essentially wait for a QR code to be scanned using the webcam. So I'm just pointing this here at my screen. Whoop, not sure exactly how I have to do this because there's no preview. There we go. And now it is asking us to type the passphrase, but as you can see, the SHA-512 hash is there. So without entering that passphrase, one can confirm the integrity of a paper backup, as I mentioned earlier. So I am typing in my passphrase, and it will ask me to show the secret. Yes, enter, foo. So there you have it. In my opinion, this is the world's most advanced piece of hardware to create encrypted paper backups, but there's so much more, and that's what I'm going to be talking about now. This device is capable of doing what we just did. There's also a command line called secure erase that can be used to secure erase flash memory. There's also a command that can be used to validate the integrity of Trezor devices. There's also a command that can be used to provision Trezor devices from a paper backup. And this has built-in support for Shamir secret sharing, which allows us to create Shamir secret sharing versions of paper backups. That means that one needs, for instance, 2 of 3 paper backups to regenerate the secret. So it uses GNU-PG encryption to encrypt the payload of those paper backups, but it also uses Shamir secret sharing so that one cannot exfiltrate data using, one of those. If it's a 2 of 3, you need at least 2 paper backups. So this is really easy to do. If you type QR backup on this, --help, you can see here a whole bunch of commands. So in order to create a Shamir secret version of it, you would want to type QR backup. Then you would want to type --Shamir secret sharing --number of shares 3 --share threshold 2 -- we can set a label, we'll call it test, and then we can actually have this device generate either a BIP39 24-word mnemonic or an Electrum 24-word mnemonic using the built-in hardware random number generator that ships with every Raspberry Pi. So create BIP39 mnemonic, enter. Now it says enter USB flash drive, so I have to switch it over to this device here. And actually, while I'm at it, I'll switch over to my overhead monitor here. Enter format USB flash drive, yes, enter. That is not a secure erase. By the way, here you can see the BIP39 mnemonic. It is asking me to type a passphrase. So I'll enter this. Again, you would want to have a very robust passphrase similar to your password manager. Enter, show passphrase. No, I don't want to reveal this on camera. And it is encrypting secret share 1 of 3. Again, we can see that QR code to register it in our password manager. That is what I would do in a real world scenario. This is just showing off this on camera. And again, no once this is done. And we're done. So what we now have is a set of 3 images on this USB thumb drive. So let me switch over to my Mac here. And if I pop open No Name, we now have a set of 3 here, which is fabulous. Doing this by hand would be prone to human error. This automates the process of creating those Shamir paper backups. Now, the cool thing with this is each share is actually encrypted with a passphrase and is protected by the Shamir secret sharing algorithm, which I might create a whole episode on. The library that I'm using is a library designed by a post-quantum computing PhD student. Maybe he's done with his PhD now, actually, in the Netherlands. You can find his name at the bottom in the, actually, I'll show off this right now. If you go at the bottom of this, let me close this. If you go at the bottom here of the page, you can see a bunch of contributors. So Dan is the guy who is responsible for this fabulous open source project. Okay, so while we're here, this part is going to be maybe a little longer. If you just want to try this out, I went through the trouble of creating sign releases that you can flash onto a Raspberry Pi. I'll show you guys how this is done. So right now, I have my micro SD card, which I am plugging into my micro SD to SD card adapter, and I will plug this here into my Mac. I haven't included instructions for this. This kind of presumes that you know what you're doing, but I'll still show this right now. So one of the requirements, if you're going to be going through this whole guide, by the way, it's a 25-page guide, so it's a very involved process, but there's so much that can be learned through the process. You have to start with a hardened Raspberry Pi, and that guide here includes the steps to flash a Raspberry Pi device. So let me switch to my Mac keyboard here. If I paste this here, we can see that disk 5 here, actually no name. Oh yeah, so that's because my mistake. No name is this here, which I will remove here. Now, if we run this again, I think it should be the same. So disk number 5 is our 15 or 16 gigabyte micro SD card. Now I want to start by unmounting this. So it's disk 5, enter. Then I need to enter my password, demo computer, shitty password. Okay, now this one didn't work, so I run this second one here, 5, enter, and we're good. I'll clear the terminal. And now we want to run this command. This is a command that you really have to be mindful when you're using it, because if you put the wrong destination, which is the off part here, you can overwrite something that you shouldn't. So please be mindful about it and maybe read up the documentation of DD. So I went about downloading, actually I need to do this here. If we go here in the sign releases, there's PyQR Adafruit. That's the version if you want to have this Adafruit hat, which is the screen. If you want to use this on any HDMI monitor, it's totally possible you use the PyQR release. So since this is on the Adafruit, you want to start actually, before we even do this, you want to make sure that whatever you download was signed by me. By the way, if you're going to be using this for your own holding, you would want to do everything from source. As we say in the Bitcoin space, do not trust, verify. But if you just want to try it out before investing all of that time, these steps are pretty easy to follow. So step number 1, you would want to import my PGP public key by running curl, then the address, piping it to gpg --import, and then I'm allowing this true little snitch. Once this is done, as you see, it was already in the computer, so that's good. Then you want to write gpg --verify and just put that path. So we're going to be doing the Adafruit version here. So you want to put the path to the zip file, enter, and it will use the downloaded SIG file Oh, actually, sorry. You have to do this with the SIG, not the zip. My mistake. So as you can see, it is assuming the right path for the zip, and it will verify the integrity of this. If you want to learn more about this, use the search on YouTube. There's an episode on verifying PGP signatures. I would highly recommend this. So now that this is done, we can pop open the downloads and unzip the adafruit.img. That .img is ready to be flashed on a micro SD card, and the default username is Pi and the default password is Raspberry. So moving back to this, we want to do this, and instead of the Raspberry Pi OS Buster thing, we want to replace all of this by our image here, and then off here, we want to select disk number 5. This is very important. I mentioned this up here. You have to really make sure that you run the command for the actual SD card, because you can override your operating system or something else. So please be mindful of this. I'm actually going to do a second test here just to be very mindful of this. So by running this command here, I can see that disk number 5, that is my 16 gigs. So I am doing if of my image of the RDisk 5, enter, and that is now flashing this release onto the micro SD card, and we'll then be able to use that as I showed earlier. So you guys will have access to the exact same thing. Doing all of this work, creating this episode, has required over 100 hours of research and work. If you use this for your holding, please consider sending over Bitcoin or a Monero donation. I have invested a huge amount of time, and if I want to keep doing more of this in the future, I really need your support for me to be able to assign that kind of time. It's a huge amount of time. Okay, so while this is happening, I will show you guys kind of how this works. So you need a hardened Raspberry Pi, you need that monitor, the Adafruit, if ever you want to have this as a kind of standalone device. You need to have a compatible USB webcam that is at least 720p in resolution that can be powered directly by the Raspberry Pi, and that's kind of harder than one would think. So I did include this documentation thing, and the one that I have is the Microsoft LifeCam HD 3000. That one is fabulous. Now, actually, not sure what this is all about here. So yeah, this here is what we're talking about. So works with blah, 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 directly powered JPEG and video. So this is the one that I am using. Okay, then you need a USB keyboard. I really like the Raspberry Pi, official keyboard here. And then you need a USB flash drive. That's the one that we're going to be storing those encrypted JPEGs on it. Well, not the JPEG's not encrypted, but the encrypted QR code stored in the form of a JPEG. By the way, when you secure erase that USB flash drive, the faster the device, the faster the secure erase. And you would probably want to find a really small one that also is very fast, and something that I've really enjoyed using. This is going to be hard to focus here, but this here is an industrial grade micro SD card that you can buy off the CoinKite website. So that's something that usually ships with those cold card Bitcoin hardware wallets. They're amazing because they're 512 megabytes, yet they're very fast. I'm trying to see here. The class is not written on them, but it's actually a very fast. So you'd want at least a class 10 micro SD card. Okay, so as I said, signed releases, as we can see here, it's being transferred, so I can just start using it, plug it in my Raspberry Pi, and it's ready to go. You guys can experiment with this. So I'm just gonna go through the guide really fast to give you guys some context as to a whole bunch of interesting aspects of this project. So you need to make sure that you're using the right keyboard layout so that the passphrases you type are predictable. Then there's a whole bunch of dependencies that we're installing, drivers for the Adafruit Pi TFT monitor. Then we install ZBar. ZBar is an open source project that allows us to scan QR codes. The version that ships with APT is kind of dated a little bit. It doesn't support the features that were needed to pull this off. So we're installing it from source. Then the SSS-CLI. That is the open source implementation of Shamir Secret Sharing designed by Dan. It's an amazing implementation. I had a talk with Dan, and it's really a trustworthy project. Then we're installing Electrum. That's what we use to generate Electrum mnemonics. And then we are installing Tmux. Tmux is to split that little screen when we are provisioning Trezor devices or validating their integrity. We kind of have two things going on. I might create a separate episode for this in the future, but you can play around with it. And Trezor CRL, actually it's CTL. I think this is a mistake here. Yeah, CTL, that should be, I'll correct that in post-production, but that is a command line that Trezor has developed that allows us to provision and access and configure Trezor devices using command lines. So given this doesn't have a graphic user interface, this is how we're interfacing with the Trezor devices. Then this is a script that uses Trezor's BIP39 reference implementation to generate BIP39 mnemonics. So this is essentially a wrapper around that work by Trezor. This is to validate BIP39 mnemonics. This is to configure those buttons here so we can actually interact with Tmux by clicking those buttons. That's a really nice improvement from a UX perspective. Then we have QR backup. I showcased this earlier. All of those commands, by the way, I'll show in the usage guide, have a little help argument which gives you guys more context on what they do. So QR restore to restore backups, QR clone, that's if you have one of those and you want to create an exact copy of it, or if you want to change the passphrase of it, that for this use case, you would use QR clone. And then there's secure erase that will allow us to secure erase flash memory. As I've mentioned many times throughout the whole privacy guide series, flash memory is very, you cannot secure erase one single file. You have to secure erase the whole thing. That is why I recommend using a 512 micro SD card for this. And this secure erase script will override it multiple times with random data, and you can also do a final pass of zeros if you want. And there's the Trezor Verify Integrity. This is used when you have a paper backup and you have a Trezor device such as a Trezor One, and you want to make sure that the paper backup matches the Trezor device. I will likely create an episode to show these features later, but you can experiment with them. Now, download and verify Trezor Restore. Trezor Restore is, say you have a paper backup and you lost a Trezor device, that can be used to restore the Trezor device. And then update, I included an update script given this device is read-only, does not have access to networking, and is designed to be kind of like a standalone piece of hardware. In order to update it, I can supply you guys with updates that are signed cryptographically, and you just plug in the update. Well, you put the update on the USB flash drive, you plug it in, and you run this command, and it will actually prompt you guys to, update the device, verifying cryptographic signatures and stuff. So that part here, shout out to Nico. That was a huge piece for me to learn about. I wanted this to behave similarly to Tails. So this here is a whole bunch of hacks to make sure that this device can work in a read-only mode, and we're then disabling Wi-Fi, and we're disabling all of the networking features, deleting a few macOS hidden files, and then we're rebooting. So at that point in time, never connect a Raspberry Pi to network ever again, although in theory, it wouldn't be able to interface over the network anyways. Then we can disable auto mount on macOS, and that's used to create SHA-512 hashes of the micro SD card. So this device is incredibly powerful and incredibly secure once the data has been written to a piece of paper. But the device itself could be compromised. Someone could compromise the keyboard or could try to compromise the actual device. So the way I see this is you provision one of those devices, sourcing all parts mindfully, and then you create the paper backups, and then this device, you can disassemble it and hopefully never use it again for this specific use case, depending on your threat model. So you may want to store this at a separate location, and the SD card itself, someone could tamper with it because it's not encrypted. It's very hard to encrypt file systems on Raspbian in the context of a Raspberry Pi because the chipset is not accelerating AES encryption, so it's painfully slow. But you can create, a SHA-512 hash of the whole micro SD card and store that hash again in your password manager. Therefore, you could see if someone has tried to tamper with the micro SD card, and those are the steps that you would want to follow for this. Then usage guide. So again, you can run --help. That gives you a whole bunch of different options here. Same applies in the context of restoring secrets, and then you can clone paper backups and do die. You can secure erase them, and I did not include actually documentation for the Trezor scripts. I guess I'll keep this for a future episode, but you can experiment with it. Let me know in the comments if that's something that you guys would like to see on camera. So yeah, that project, that Raspberry Pi project, I invested so much time into it to scratch that itch I had. I really disliked normal paper backups. I find this is like so much more robust. Hopefully this was insightful. If you have questions, let me know in the comments or on GitHub discussions. By the way, if you like all of this open source work I'm doing, please start a repo on GitHub. And yeah, I'll see you in the grand finale of the Bitcoin series in next episode. And then we're back on track for regular privacy guides. I have a lot of stuff that I'm looking forward to share. My mental model has shifted a bit, so I'll be sharing all this shortly. Thanks. See you soon. Bye.